Today on Tekavou, we're creating videos out of Etch-a-Sketch drawings, we rediscover techniques that Disney animators used decades ago, we figure out why this camera now looks like a Wii accessory, and by the end of this video, this project will have become significantly weirder as we accomplish a world's first. So get ready to turn reality into one continuous line, today on Tekavou. Hello friends, and welcome to another episode of Tekavou. In a previous episode, I built an Etch-a-Sketch that had an undo button, and because of scope creep, I was able to get it to play video games as well, and also draw its own art. And then I built this little guy here, the Tekavou. This is the world's first camera that can not only take pictures, but also transform them into Etch-a-Sketch drawings. It kind of looks like you're trying to sketch on a bumpy road, but it looks really cool. Today we're going to bring this project to its final form. We're going to make it record Etch-a-Sketch videos. I know on paper this sounds really simple. A video is just a bunch of pictures that are played back quickly. Playback isn't even the problem here. Every single image just takes forever to render. I can watch an entire season of a show while it renders. The goal here is to bring that down to something more reasonable, like the time it takes me to watch an episode, or better yet, a YouTube recap. What even is an Etch-a-Sketch video? Well, in the last video, we had defined an Etch-a-Sketch image as a drawing made entirely of one continuous line with no jumps and at least one space between lines, and it doesn't rely heavily on diagonals. For video, it's going to be the same thing, but with continuous motion. So this begs the question, why is it so hard to make an Etch-a-Sketch video? If I already figured out how to automate pictures, can't I just make it do video? Well, it all comes down to time. Right now, making a simple Etch-a-Sketch image can take a while. And when you turn that into video, things just slow down dramatically. If you think about it, a video like the one that you're watching right now is 30 images in 1 second. It took me 15 minutes just to record 1 second of footage. And that got me wondering why. When we look at things like Instagram or TikTok, they can slap effects into video in real time. So is it my code that's really bad? No, not exactly. Think of Instagram as putting makeup on a face. The face is already there, you're just adding a filter on top. What I'm doing is more like asking somebody to redraw a face from scratch, using only one continuous line, and they can't lift their pen, ever. An Etch-a-Sketch is very unforgiving. Once you commit to a line, you're in it. You can't change your mind afterwards. You need to think ahead of time to figure out where all of your drawing points should be. For every single frame or picture, I need to figure out exactly what matters the most, ignore everything else, and then plan a path that a real Etch-a-Sketch could physically draw. And once that's done, I have to do it again and again and again, up to 30 times just to get 1 second of video. So now you can see why it's taking forever. So if I want this to be usable, I need to make it way faster. The first obvious idea that I have is to drop the frames. Instead of 30 frames per second, what if I try 20 or 10 or even 5? What does that look like? At a certain point, it just stops feeling like a video and it starts to feel like a PowerPoint presentation. A real video is high fidelity though. With an Etch-a-Sketch, maybe it won't be so bad. Let's see what happens if I take a few rendered frames and play them back slowly. And now if I remove a few frames? It's not terrible, but it doesn't feel right either. It feels like I'm cheating the video instead of fixing the problem. And I don't think this is the solution that I want. Let's rethink this. Right now, each frame is getting drawn one at a time. Dropping the frames didn't feel right, so instead of making the video less smooth, I wondered, what if I cloned myself and drew more frames at once? This sounds a little bit absurd, but stick with me here. Imagine if I had 12 versions of myself, each one drawing a different frame. The total amount of work wouldn't change, but it would get done 12 times faster. And as it turns out, that's basically what my computer already has. My computer has 12 cores, and each one of these cores can work on a different frame at the same time. Suddenly, I don't need to do a full rewatch of Game of Thrones while this renders. I only need to watch one season's worth, maybe one of the earlier ones. This is a huge improvement, but it's still not fast enough. And this is when I realized something. I'm tackling this problem the wrong way. Even with 12 versions of me working at once, I'm still doing too much work per frame. Every single frame is being treated like a brand new one. All the analysis that I did in my previous frame to determine the paths, they're all gone. This would have been fine if nothing stayed the same, but in a video, most things don't change. In a normal video, the background is usually the same and the subject and some small parts are the only things moving. Right now, for example, I'm the only thing moving. My background's not actually changing. And then I remembered, this isn't even a new problem. Old Disney animators figured this out decades ago. They didn't redraw the entire scenes for every single frame. They only drew the differences. They would keep the backgrounds exactly the same, and most of the characters stayed the same as well. Then they would lay a transparent sheet on top and only redraw the parts that actually moved. I don't need to draw the full frame each time, I only need to draw the differences. This feels obvious now, but I wasn't thinking about these kind of optimizations when I first started the project. For an Etch-a-Sketch, this changes everything. Instead of trying to find every possible connected dot path in each frame, I only need to worry about the dots that actually moved. The tricky part here is trying to figure out which parts of the image change and which ones stayed the same. A simple little hack that I decided to use was to split the frame into a grid. Whenever I don't know how to solve a problem, I just start putting things into little squares and hope for the best. Now that everything is in a grid, when I jump to the next frame, I simply compare each tile to the previous one and make sure that nothing has changed. I do account for things like video noise and compression artifacts, but in general, if a tile looks the same, I can just completely ignore it. And this changes everything, because suddenly, instead of redrawing the entire frame, I'm only redrawing the parts that actually matter. This is not only great for performance, but also my electricity bill. And the speed difference here is dramatic. This is finally YouTube recap fast. My original version took me 45 minutes to render a very short video. When I split the work across multiple cores, that dropped to about 4 minutes. And once I stopped redrawing everything and only focused on the changes, it now only takes me about 2 minutes at most. Now that the hard part is done, let's see what this looks like. Whoa, I think I pressed the wrong button here. Okay, now for the fun part. Let's see what the matrix looks like as an Etch-a-Sketch. Hold on a second. Because I apparently can't work on a project without opening 3 side quests in my brain, I sent one of my friends the analysis version of this clip. I was expecting them to be blown away, but they just responded with, "This is the Matrix. Shouldn't this be black and green?" The entire movie is already color graded like somebody spilled Mountain Dew all over it. So yeah, I really do think black and green makes sense. So naturally, I had to try this. Okay, no joke, this looks way better than I expected. But now this got me thinking. What if I didn't fake the colors for one specific movie, but I did it for every single clip? What if for every single point in the image, I looked at the actual color underneath it, and then I drew the connecting line using that color? And that, my friends, is how I accidentally created the world's first colored Etch-a-Sketch video. Look at the difference here. Mario 64 just pops with color. The color adds so much depth to the final image that it almost stops looking like an Etch-a-Sketch entirely. Adding the color didn't even make it that much slower. At this point, the project is finally fast enough that it's usable. We've certainly come a long way since my original Oh No Lisa. There's still one little problem that's lingering. All of these tests are happening on my computer using carefully selected clips. Kind of feels like cheating a little bit. Because if this thing is going to feel real, I can't just have it working in perfect conditions in my office. It needs to work out there, in the real world. And for that, we're going to need to bring back this little monster. The Tekavou. And since that last video, it's evolved a little bit. You might notice that the back is now red. And that's because after my original build, the SD card overheated and melted the whole project down. I had to rebuild the entire thing from scratch, which explains why it took me so long to release this video. The red here is a reminder of the importance of thermal management, but also because I ran out of blue filament. My original thermal strategy was mostly based on hope. This one is as well, but now I have bigger vents. And honestly, I kind of love how it looks now because you can actually see some of the internals through the shell. I even bought a thermal camera just to test it out properly. And also because I've reached the point in my life where buying a thermal camera is an exciting purchase. The other major change here is the battery. I moved it outside the camera body entirely, so now the Tekavou has this weird little nunchuck attachment. Not only does it make the device feel more powerful in my hands, but it also kind of makes me want to play Wii Sports. Now technically, the Tekavou doesn't actually do the full Etch-a-Sketch conversion itself. For photos, the workflow is pretty simple. The camera captures an image, stores some extra metadata that helps it with the conversion process, and then it sends all of that information back to my server. For video, it works a little bit differently. Now the Tekavou also helps figure out which parts of the scenes actually change between frames. That way, before the footage ever reaches my computer, we've eliminated a huge amount of unnecessary work. And that means faster renders, which means less waiting, which means I can finally do the thing I originally wanted to do with this project, which is to go outside and turn real life into an Etch-a-Sketch video.